Hi friends, in this video we will discuss one of the electrophilic substitution reactions of amine, which is nitration. So nitration of aniline. We consider aniline here, and aniline have a lone pair of electrons over the nitrogen atom, so it's a plus R group. So it shows plus resonance effect. So it's an ortho para directing group. Orthopara directing group. What does it mean? Orthopara directing group. It directs the incoming electrophiles into its ortho and para positions. So the resonating structures of aniline is already discussed in our another video in bromination of aniline. That video we have already seen. If you wish to see, I will give the link of that video in the description box. So we'll see the nitration of this aniline. So for nitrating, we always use nitrating mixture, right? So nitrating mixture is a mixture of concentrated sulfuric acid and concentrated nitric acid. And this concentrated sulfuric acid and nitric acid together form one electrophile. Which electrophile it forms? NO2 plus. This is the electrophile formed when you take the mixture of concentrated HNO3 and H2SO4. So this will attack ortho and para position. So we are expecting two products here. One is para nitroaniline and ortho nitroaniline. And whenever we have two products like ortho and para derivatives, para is the major product due to the steric reason. So this is the major product and this one will be the minor product usually we get. But here when you see the percentage composition of this para nitro, we can see that it is almost 51%. 51% of the compound formed is para nitro, and this one is only of 2%. So 51% para nitro and 2% ortho nitroaniline. Where is the remaining 47% of this compound? Is there any other products formed? We know that aniline is an ortho para derivative, so you always get one para derivative and one ortho derivative. But here, both of them together only 53%. Where is the remaining 47%? What is the other compound form? Here we will see the explanation of that. See, aniline NH2 group is a Lewis base, and we add concentrated sulfuric acid and nitric acid in that. That means strong acidic medium we add. So in this strong acidic medium, this aniline gets protonated to form anilinium ion, acid-base reaction. Since one is aniline is a Lewis base and we add strong H plus ion in that. So and NH2 accept this H plus ion to form anilinium ion. This one is anilinium ion, NH3 plus. Anilinium ion. And anilinium ion doesn't have any lone pair of electrons over nitrogen since it is already used to make bond with the third hydrogen. So this compound is a minus R group. Minus R group. Minus R means it withdraw electron density from the benzene ring. So minus R groups are meta-directives. Minus R groups are meta-directives, or they are meta-directing groups. They are meta-directing groups. Then this anilinium ion again reacts with concentrated sulfuric acid and concentrated HNO3 to form meta-nitroaniline. So this is almost 47% of all the three compounds. So when you nitrate aniline with concentrated sulfuric acid and nitric acid, we get three products. One is para nitroaniline, which is of 51%, and meta-nitroaniline, which is 47% of the total compounds formed, and 2% of ortho nitroaniline is also formed. Now, if you need only para nitroaniline, how we will prepare? Preparation of para nitroaniline. So in the previous structures we have seen that meta-nitroaniline formation is only due to the protonation of aniline, right? So here, to prevent the formation of meta-nitroaniline, we need to prevent the protonation. That means that lone pair electrons over the nitrogen atom must be blocked there or must not be available for protonation. So for that, what we are doing is we take this aniline and acetylate it using acetic anhydride CH3CO twice O, acetic anhydride, and you will get acetanilide. Here you can see that the lone pair of electron of this nitrogen is engaged in resonance. So it is less available for the protonation compared to the lone pair of electrons available on an aniline. So when this compound, when you nitrate it again, concentrated H2SO4 and concentrated nitric acid, the product formed will be para-nitroacetanilide, CH, NHCO, CH3. To get the NH2 group back, we can hydrolyze it. Then this NHCO bond will cleave, and then you get NH2 and NO2 here. So you will get para-nitro derivative as the major product. So now the reactions to be are done. First we need to acetylate it. So what is the need for acetylation? By doing acetylation, we make this lone pair of electrons over this nitrogen busy with the carbonyl group. So the availability of this lone pair of electron for the availability of this electron for the reaction with protonation is less, or this reaction does not take place, or the reaction is less. So the amount of meta-nitroaniline formed will be very less. Hope you understood the topics. Thank you.